Assalamualaikum and hello everyone. Welcome back to Chapter 5 Vectors. In this video, we will proceed with 5.4 Application of Vectors in Geometry, Part D. Determine the angle between two planes and a line and a plane. So we start with angle between two planes. The angle between two planes, phi1 and phi2, defined as the angle between normal vectors n1 and n2. By scalar product definition, to find angle between two planes is theta equal to inverse cos of n1 dot n2 over magnitude n1 magnitude n2. Remarks: n1 is perpendicular to n2 will be n1 dot n2 equal to 0. If n1 parallel to n2, it means n1 cross n2 equal to 0. So let's try a few examples. Example 14a. Find the acute angle between two planes. So by the acute angle, it means our final answer must be less than 90 degree. So based on these two planes, we can identify the n1 and n2. So now you have to find the magnitude of n1 and magnitude of n2. So next, we have to identify the dot product of n1 and n2. Then you have to substitute these three values into the formula of inverse cos, negative 1 over 3 times 3 square root of 3. So we're going to have the value which is equal to 93.68 degree. But that's not our final answer, because your final answer must be less than 90 degree. So it means you have it to subtract from 180 degree. So your final angle, we're going to have 86.32 degree. So let's move to the next example. Example 14b. Find the angle between these two planes. So as usual, from these two equations, we can have it the n1 and n2. And you have to find the magnitude of n1 and magnitude of n2. So next, you have to find the dot product of n1 and n2. Then we have to substitute into the formula. So we have inverse cos of 3 over square root 21 times square root 38. And we will get the answer equal to 83.90 degree. So next, angle between a plane and a line. The angle beta between the line and normal to the plane is given by inverse cos of n dot v over magnitude n magnitude v. But that's not our final answer, because we are looking for the theta, which is the angle between line and plane. Then you have to minus from 90 degree. Example 14c. Find the angle between a line which is parallel to vector 2i minus j and the plane r dot 3i plus 4k equal to 5 by drawing a diagram. So we know that we are looking for the beta first. And then lastly, we need to find the theta. Since the line is parallel to 2i minus j, so directly we know that your v is equal to 2i minus j. So you can find the magnitude of v first. So we're going to have square root of 4 plus 1. So we get the magnitude of v equal to square root of 5. And then identify the normal vector. So we're going to have 3i plus 4k. So the magnitude of n equal to square root 9 plus 16, which is square root of 25. And we can simplify to be 5. So next, find the dot product between n and v, which we're going to have 6 plus 0 plus 0, and we get 6. Then we substitute into the formula, which is by beta equal to inverse cos of 6 over 5 square root 5. And you will get equal to 57.54 degree. Remember, that's not our final answer. We are looking for the theta. So theta equal with 90 degree minus beta, which is we have 90 minus 57.54 degree, and we will get the final answer equal to 32.46 degree. Example 14D. Find the angle between straight line and the plane. So identify your V and N, and magnitude of V and magnitude of N. So next one, find the dot product of V and N. Equal with 1. So your beta equal to inverse cos of 1 over square root 17 times square root 11. Therefore, your beta equal with 85.81 degree. So our theta will be equal to 90 minus 85.81 degree equal to 4.19 degree. Okay, so by this summary, I hope you can identify or you can differentiate well on how to find the angle between two lines, between two planes, and between a line and a plane. So that's it for now. I will see you again in the next video. Take care and bye bye.